Voxeljet presents the VX2000, the industrial 3D printing system for the cost-effective manufacture of sand molds and cores for metal casting. The available build space measures 2,000 litres. This enables the fast and flexible manufacture of mold components of different sizes and complexity in a single printing process. Tool-free manufacture is ideal for the production of complex cast parts, for the faster production of prototypes, small series and spare parts. The layered building process is shown using an example of a motor block. The CAD data of the molds is arranged virtually in the building space. This build space corresponds to the job box of the VX2000. The job box is loaded into the machine. The printing process starts with the coater and the even application of a sand layer. A high-resolution print head then applies the binder only at the points at which the mold components are to be created. The building platform of the job box lowers by the layer thickness. This process is repeated until the components are completely printed. The mold components are then freed of unprinted sand in a separate unpacking station. The molds and cores can be used directly for the casting without time-consuming reworking or combined with conventionally created molds. The VX2000 optimizes complex cast parts of different sizes through cost-effectiveness and time savings. Find out how Voxeljet can optimize your production.
Hi, good afternoon, Nidhi.
Good afternoon.
This is Tejal from 3D Graphy, and just want to ask you some basic questions. You have been a very good women entrepreneur, which is in the 3D industry, to have a woman entrepreneur going to such peak level and taking good interest, and you made a mark in the industry in India. So would like to ask you and share a little bit about Voxeljet and how was the foundation laid. And
So first of all, Tejal, thank you very much and thank you for your kind words.
Yeah.
For me, with Voxeljet was a really easy decision for me because I've been a part of 3D printing since 2003. And during my many travels to Europe, especially to Germany for various 3D printing events and exhibitions, I've had the good fortune to meet with the team at Voxeljet to learn about the technology and what they have to offer. And when I was transitioning from my time at Imaginarium, taking a break, and that's when I came across Voxeljet, and as a part of my consultancy at the time, I was approached by one of the large pump and valve manufacturers in India who were looking to adopt 3D printing of sand molds and cores, and very curious to know about the technology. During that consultancy, we were able to connect Voxeljet with them, and since then there was really no looking back. That really gave me a lot of confidence. First of all, in the technology, I learned a lot about Voxeljet, but also on the other side, it gave Voxeljet a lot of confidence and know-how into the Indian market. And at the end of that, both of us decided that we are a good fit and we should really explore the Indian foundry market for Voxeljet. So I think it was an easy fit for all of us.
would like to know your expertise is in casting, and especially as you had mentioned that the old convention method, which was a traditional method, was not helpful, but now in India, there's a lot of boom in 3D industry in various areas. So we would like to know where is your expertise, especially in regards to 3D binding, jetting and sand casting, or if you have any other thing to share.
So for Voxeljet, our focus and our niche has always been the foundry industry. We manufacture these large frame industrial 3D printers that can 3D print sand for sand casting, LPDC, GDC, and also can 3D print wax patterns for or PMMA for investment casting, and that's our niche. That's our expertise, if I may say so. Over the years, so Voxeljet completed 25 years this year worldwide.
Congratulations.
We've been around since 1999. And over the years, we have worked with, because foundry industry is relevant to almost all industries, whether it is automotive, oil and gas, medical, engineering, mining, and all of these industries cumulatively have used Voxeljet's technology, and they have used the technology to add a lot of value to their existing business. I would say from an Indian perspective, where Voxeljet's strength is and where we've really been able to add value is for low volume critical castings, whether it's for pumps and valves, especially in oil and gas or chemical pumps, process pumps, nuclear pumps, etc. Or we've also done a lot of work with automotive foundries who supply to the automotive industry, especially for very critical cylinder heads and blocks or manifolds and such applications. Having said that, slowly we are all, because you know that there is a lot of tilt towards aluminium for the last couple of years with the advent of electric vehicles and also a lot of aerospace that's coming into India. We are seeing a lot of LPDC and GDC foundries, so low pressure gravity die casting and GDC, which is gravity die casting. Both of these kind of foundries are reaching out to us for their very critical applications in aluminium casting, whether it is for EVs or aerospace applications. So that is another area which is growing for us in India. This is something which has already been relevant for Voxeljet worldwide for the last few years, but now in India that is another trend that is picking up.
So you see that in future in Indian industry, we will have wider exposure, that's what you're saying?
100%. Foundries now more than ever have realized that to position themselves or to really add value to their existing business, they will have to adopt new technology. They will have to adopt advanced technology, and status quo will just not cut it in terms of getting really good growth and to ride the wave of the China +1 policy. So we are seeing a lot of foundries that even though they are doing really well with the conventional process, are looking to diversify and add technologies, not just 3D printing but also other advanced manufacturing technologies into their system to give them meteoric or exponential growth and to, as I said, to ride the wave of the China +1 policy.
Right, and definitely the 3D current technology is way better as compared to the traditional, as you said, because it saves time, right? Time and cost-wise.
Yeah, you're right. So I would not say that 3D technology is better than the conventional process in all projects or across the board. I think it always depends from project to project or product to product or application to application. There are certain applications where 3D printing is a very natural fit. So when you're looking at low volume complex critical castings or batch volume production of critical castings, then 3D printing is a very natural fit. But when you're looking at making really simple cores in hundreds of thousands of numbers over the years, then probably 3D printing is not a natural fit. Then the traditional process works just fine. So depending on your project and your requirement, the foundry will have to choose which technology works best in that scenario.
Thank you. And you said you'll handle the critical cases.
Yeah.
Even the geometrical, right?
Yeah. Yeah.
So how would that benefit if
Sure. So I think the biggest advantage of 3D printing technology in general is to be able to manufacture really complex geometries. Specifically for castings, when you have really complex geometries with thin cross sections, undercuts, etc., to make a pattern and a core box for this becomes extremely difficult. And even when you do, you have to assemble the mold and core in multiple pieces. When you assemble a mold in multiple pieces, you give rise or you give the you increase the possibility of having a lot of errors in the assembly, you increase the possibility of having a lot of parting line flashes, etc., and hence lot of rejections. But with 3D printing, because you are manufacturing the part by depositing material layer by layer, hence it is additive manufacturing and not subtractive manufacturing where you are removing material. That's why it gives you a lot of flexibility to build really complex geometries and complex structures. And this means that you don't have to worry about draft angles or really thin cross sections, etc. And that's how 3D printing really helps with these complex castings, that you can consolidate multiple pieces into a single piece, thereby reducing your chances of rejection or rework.
Thank you, Nidhi. Would also like to ask you that as 3D is also a consortium and we are reaching out various industries.
Yeah.
So, what future do you see with 3D Graphy, and would like to see something about 3D Graphy?
Sure. I have known Shibu for I think a decade now, or more than a decade. And I really applaud his initiative in bringing the users and technology manufacturers together, bridging the gap. Because a lot of times the users don't know what technologies are available out there. This is one part of the equation. Other part of the equation is a lot of machine manufacturers like ourselves don't know what the customer is really looking for and how to approach the customer and support the customer, and that's where 3D Graphy can kind of work as a matchmaker and is already working as a matchmaker to bring the two parties together in a meaningful way where it adds value to everybody involved in the process or in that project, and I really applaud that initiative.
Thank you very much, Nidhi. We wish you the best.
Thank you.
And may you expand more. Appreciate it.